Hello and welcome. In the last sessions, we have discussed about lists, dictionaries, tuples, strings, numbers, and we also discussed about conditions, looping, and how to organize your code at the first level, that is the functional level, how to write functions and use them. Today, we are going to discuss about another level of modularization. This is again a way of organizing your code. So let's begin with modules. Okay. Uh, all right. Before we begin, do you have any questions so far?
Not yet. Oh, and I saw this session 14 and license session 10. Does the number matters?
So did you go through the session which talked about dictionaries and tuples?
Yes, the last session was about those.
Okay. So we have not recorded any sessions after that. Okay.
Okay.
Uh, do you have questions so far?
No.
Okay.
Not yet.
I asked one program. So did you try that? Were you able to do the same program in the
Yeah,
functional way?
is that descending
Right,
descending
exactly. Right, right.
um, yes, I wrote that.
Okay, you have tried that?
Yes.
Okay. So, do you have any problem with that, or you want to share
No.
your share a code?
Um, about I don't have questions and I can share.
Okay. All right. So in that case, um,
Mm,
maybe you can email me your code. Okay.
mm, how do I
Or
share the code?
okay. Just that I wanted to see whether you have done it right way,
Okay.
or I can just go through it right now. I can make you a presenter and you can just show me a code.
Okay.
Okay. All right. Mm-hmm. Okay.
I forgot to. This is the one sorted, and this is the original list.
Okay. So let me have a look at the code. Okay, so you have splitted the text, then printed it's fine, and Okay. Um, okay, I have a suggestion here. Okay.
Mm-hmm.
The code works fine. That's
Mm-hmm.
okay.
Mm-hmm.
But now, when you give any argument to the function, right? So, for example,
Yes.
you are passing in reverse is true, right? Don't give
Mm-hmm.
spaces over there, right?
Mm-hmm. What's
Yeah,
that?
so what I mean to say is when you do words dot
Mm-hmm.
sort and then you
Mm-hmm.
say, and in the sort function you pass in the argument reverse if
Oh,
true, okay? So
yes.
don't give
Yes.
space after before
Mm-hmm.
is equals to and after is equal to.
Before.
So reverse
Uh.
reverse
Mm.
equal to, there's a space over
Mm.
there, right?
Oh, yes.
There's a white space, right?
Mm. Mm.
So that's not a good practice, but it though it may work, but it is not recommended to give a space over there.
Oh, so should it be like this?
Yes, exactly right.
Okay. Thank you.
Okay. Otherwise the code is fine. Yeah, that's great. Okay.
Okay. Thank you.
Okay. And all right. Um, mhm. Um, I'm sorry. I think I pressed the wrong button. Yeah.
Yes. Yes.
Okay. So let's
Yeah.
begin. Yep.
Okay.
That was a good small short code which you have written. All right. Now, and we will also talk about good programming practices in coming classes, which are like few of these standards. We'll be talking about PEP 8 standards, which is the Python standard coding for styling, which you should follow. All right, now today let's look at modules. As I said, this is another way of organizing your code. It's in a better way. So let's look at it. So here in this slide, I have two functions. All right. So two functions are, as we said, that functions are also a way of organizing your code so that your code becomes reusable. Now, modules are nothing special than regular Python programs. All right. So what you see as your py files, right? So whatever you see as .py are in fact modules, right? But we call them modules only when these files are most reusable. Most reusable. All right. What I mean by that is, say for example, you've got a file which you have written. Say, let's take your example of sorting, which you did right now. Sorting.py, for example, the file name is sorting.py, and you had couple of statements over here. Starting with you had raw input, and then you tried out some print. All right. Okay, so what happens if I treat this particular file as a module? Can I call it a module? Yes, you can call it a module, but it's not recommended to write any code in the module which is not reusable. All right, so a good module is um, where you can reuse most of the code. Most in the sense, if you write 100% reusable code, that is called a best module. Okay, now just a minute, let me see. Okay, fine. All right, so now what we are trying to do here is we have got two functions. One function is Fibonacci series. So this function calculates the Fibonacci series up to number n. You pass in a number and the Fibonacci series till that number is printed. All right. The second function is calculating the factorial of a number. All right. Now I have clubbed these two functions and written down in a file named fibo.py. Right. Now my file fibo.py has got these two functions in it. Okay, now since we know that functions are completely reusable, right? They are executed only when we call them, and hence they are reusable, right? Okay, now let's see how do we make use of this file as a module and and try to accomplish our task. What is our task? Now, if say I want to calculate only factorial, all right, I can write down the same single function in a separate file and execute it. That's true. But what we are trying to do now is we are trying to club all our functionality in a single file which we are calling as module. All right, and then we are using it, we are using part of it, that is maybe one function, maybe one class, or creating an object. We are using part of it as and when required. On a need basis, we are reusing the functionality in part or incomplete from a module. Okay. So the module is now, if we say a conclusion on a definition of module, it is a collection of reusable codes. Now reusable code can be written in functions, can be a class, right? Now clubbing all this together is a module. Now let's see how do we make use of all these functionalities in our script. Now, important point to understand here is about how do you differentiate between a script and a module, right? So I say it this way, that I have got these two files. One file is script.py, another is module.mod.py. Okay, I'm calling this file, as we said that modules are nothing special than regular Python programs. Okay, now I'm calling this Python program as module. Okay, and I'm calling this Python program, which is script.py, as a script. But why? Right. Again, the differentiation comes in that maybe my script is not having complete reusable code, rather it is using the reusable code present in module mod.py. Now what we have done is, let's rename this and let's say this is my fibo.py, which we just named for our file, which contains two functions, fib and fact. All right, so I will say this is fib and this is fact. These two blocks, as you can see here, right? Now, this is a complete reusable code module. Now we are trying to write some Python program which will make use of this reusable code here. Now, how do we use this piece of code? Now, what we want to do is, just a minute, let me change the color. And I want to use this piece of code over here, this piece of code over here. All right. So how do I do that? I need to bring my piece of code to this namespace. When we say namespace, is we are making it existent in this piece of space, right? So that this script.py can use it. That is done using a keyword which is called import, right? You import the functionality. Now there are many ways of importing the functionality or importing the module. So you can import the complete functionality of module, or you can import in specific functions or specific classes from the module. Now, as this says, we are trying to import Fibo. Now Fibo is where Fibo is the name of our module. Remember, when you are importing, you're not giving .py here. All right, you don't have to give this, right? You just give the name of the module and it works. Okay, you don't have to give the extension. You say import Fibo. Now Fibo comes in the namespace of it is made available over here. Though in our code shown here we are using the interactive shell, so it gets available over here. If you are using the same import in the script file, it becomes available in the script file. Now, using the module, so you have to give this is called, how do you how do you execute the functionality in the module. So you say Fibo is the name of the module dot, this is a way you access the functionality using the dot notation, right? All right, so you say fib is the function. Now I want to calculate the Fibonacci series till number 1000, and you see you get the Fibonacci series over here. I don't have to write, when I'm doing a module, I don't have to write separate scripts, separate Python files for each functionality. I have clubbed in both the functions in only one file. That is an important point to repeat. Okay, so keep in mind, so we are clubbing all the functionalities in only single Python program, which is called module. Okay, and then reusing it. This is the first reuse. We try to use the fib function inside the Fibo module, and then let's see how it is the okay. Now how do you use it often? This is the other way, right? And how do you use it often? Is you store the address, right? You store that, hey, I want to store the name of the function over in a module, so that I don't want to give the complete access like dot notation. I don't want to do this. So I want to store the name in a shorter form, and then when I use it again, I don't have to give the complete notation, right? So I say, next time when I want to calculate any Fibonacci, I just say fib of 500. All right. Okay. Okay, this is a different way of importing. As we said, you can either import the complete function. In this case, in this particular case, we have uh, in this case we have not here. Here we have imported the complete module. Okay. Now, in the next slide, what we have shown is this portion is importing a specific functionality. Okay, now anyways, in our case, we have got only two functions. So this statement imports both fib and fact. Okay, so this particular statement imports both fib and fact. Now, what is the form of this import? From fibo. So I'm saying that from the fibo module, get me this fib and fact. If, for example, we had three functions, say we had fib and we had fact, and then say we had something add or multiply or something, right? So my module contained four functions, right? I said that this is fibo.py, but I am importing in this case only fib and fact. I'm not concerned about add and multiply anymore, right? Because I don't want it right now. So I can just import the specific or required functionality from a module instead of completely importing it. All right, and then when you do like this, you don't have to um, access it, access the function giving the module name and dot notation. Okay, you can directly call the function when you're using the import form from. Right? When you're using from module import some functionality. Okay, when you're using this form, you can directly use the function name and call it. Okay, all right. Okay, this is very important aspect, as in when you're dealing with modules and scripts. This is important. So what does it say? Save it as modls.py. All right. When we want to differentiate between that our module is run standalone or it is being used by some other program, how do we differentiate it, right? So there is a special variable, a special uh, keyword which is called underscore underscore name underscore underscore. People call it underscore name, right? So underscore name. This is the special variable which stores the name of the file. Okay. Now let me try to demonstrate it if I can. Hold on. Okay. Okay. So this basically is intended for example, let me just create quickly a file where I just say import fibo and just print amscript.py, and I also want to print the value of this special variable. Okay, I want to save this as script. Okay, I already have it. Okay, let me see what is the content I have here. Okay, that's the same in fact. And what does this have? No, let me just check this. Okay, and the Fibo. Okay, all right. So this will work. All right, I already have it. Let me just try to execute them. No, I don't want to save. I already have it. And file, open, script.py. So you see, what have I got here? As I was discussing in the first place, let me just go back here, close this for now. Here, okay, this is what is we are trying to understand. Okay, so I've got this file as script.py. Okay, and I've also got this file fibo.py. I'm calling this as a module and this as the script where I'm trying to use the module functionality. All right, so this is my script.py where I have imported the module import fibo. Okay, and I'm trying to print the value of this special variable called name. Let's try to execute this and see what do we get. Okay, I'm trying to run this. Hopefully, yeah. Okay, cool. I got an error. I have got the output over here, and as you can see, the first print comes from this name. Okay, let me try to run it again, giving a differentiation. Doesn't look good. So I am at script.py, and I also say okay, not here. All right, and let's see what do we get. Okay, that slash n has anyways that doesn't make any difference over here, so I think it previous was good. Okay, okay, this looks good. Okay, let me just close this and run again so that it is much clearer. Okay, now what I'm trying to explain over here is that this Fibo print has come from, okay, can you guess? This Fibo has come from not any of the print in the script.py. Let me try to open both of the files together and fibo.py. Okay, so I've got these two files over here. Okay, and I have also got the output. Let me try to place all three together. Okay, all right. Now this Fibo print has come from this print, which is print name. Okay, now when I said that the special variable holds the name of the file we're dealing with, so since I try to run what script.py, but it imported Fibo. Okay, now important point to remember here is any module is executed only once when it is called, and when it is called, it is when it is imported. So any module is executed when it is imported for the first time, right? Now in our case, the module FIBO is executed when it is imported at script.py. Okay, so when we did import FIBO, this module is executed. FIBO is executed, and hence you get two print statements coming from here. Though you have not run FIBO separately, you have just imported FIBO and run script.py. You see, I just tried to run a script. I did not run FIBO, correct? Okay, but when you did import FIBO, this module gets FIBO module gets executed, and you get these two prints coming in. Now, remember, when any module is being run standalone, right, the name of the file comes as main. This is important to note. Okay, now since this FIBO is imported and it is not run as standalone, that is, when we, okay, let me try to show you this part. Now you see what happened. I tried to run FIBO as a standalone rather than running script.py, and I do not get any prints of the script.py because I have not imported script module anywhere as a module, right? So I get what main. As I said, that any when a script file, when a file, Python file is run standalone, the name variable, this special variable holds the value double underscore main double underscore. Okay, and then this print has come. Okay, now in this case, in the first case, when I try to run script.py, the name of the module comes as FIBO. That it says that, hey, right now I am running in the scope of FIBO, right? I'm not running in the scope of script.py. Okay, and then followed by this print, and here I come with this part. And what is this? Okay, this is the print statement over here, and then at the last, and then I've got a new line, and then at the last I have got main. Okay, I hope this clarifies the scenario of the underscore underscore name variable and its importance to differentiate between being run as a standalone or uh, getting imported and run, right? So this is the comparison typically you would find in any of the Python project you see, right? The comparison is done in this way, that if the name variable holds the value, now we saw that the value, the output of this name variable was main. So this is a string basically. Okay, it is a string, the name is a string. Okay, that's why we are comparing this as a string, that if name variable has the value main, that means this module or this program is being run standalone. All right, otherwise, okay, it is just called from some other module or some other script. All right, okay, since this was like, I doubt sometimes people don't understand maybe. So Jan, did you understand this?
Yes.
Okay, great. I was doubtful that people sometimes don't understand this. Okay, great. Okay, let's move on with how do you write a module so that Python is able to search, right? Can you write a module in the D drive or any drive you have in your computer and then execute it? Okay, I mean, until and unless your module is searchable by Python, you really cannot try to execute a module. Okay. So how does it matter, right? We need to put our, so when you do import any module name, Python goes over in this path. Okay, the variable sys dot path is searched for all the possible modules. When you do an import, this is being searched. Okay, all right. So let me try to show you where it is. Okay, okay. Now I say import sys because I want to make use of the functionality in sys. And what is the functionality? I want to check what is this sys.path value. Okay, so these are the paths. Okay, what is this? This is a list of paths. This is the list of path, all possible paths where all the modules would be searched for. If the module is not found in any of these paths, you're going to get an error. Okay, all right, and let me show you in fact this way, that I will just go over and um, in C Python 27, and I've got Fibo and script.py. Well, let me just try to move this Fibo. Okay, I'm trying to move this Fibo to say where. Okay, I'm just trying to move in a new folder. Okay, I say this is Fibo. Okay, and I paste it over here. Okay, let me try to run my script. Right. Okay, here is the script which imports Fibo, and I try to run this. All right, so you see this error. This error is clearly saying that there was no module named Fibo found. But then the user, if he or she doesn't know that it has to be in any of these paths, right, will say that, hey, I have got this module, how come this is throwing an error, right? And in fact, you can argue that, hey, I've got this Fibo folder where I have this module, right? So what you need to do is, there are two things. Either you write your module to be present in any of these paths, which you get using the sys.path. You print sys.path and you get the list of paths. So you can either write your module in any of these paths, or else you can append your existing path where you have written the module onto this list, right? So you can say sys.path.append. And how do you append? I want to append, I don't know, I want to append this. So let me see if, okay, I want to append this. Okay, I just imported it. Okay, now let me try to print the path. Okay, I have got this particular folder, this particular path added. Let me try to run the module now. Hopefully it should work. And then I say run the module. Okay, I'm not sure why this is throwing an error. Okay, any difference? Okay, maybe is this accessible? All right, that's a bit off. Okay, let me try to open this again. And okay, ideally this should not happen. I'm not sure. Just on it. Okay. In fact, that's the correct path. Let's just rename this to Fibonacci. Hopefully that is not causing a problem. And okay, so what I believe here in this case is that I don't have much of permissions to enter this folder. Okay. Otherwise, if you try to add this, otherwise you should be able to access once you have added your code path to. Okay, there might be one case. Just a minute, let me just have a look. This also might not be the issue. Close. And let me try to place this in this. All right, and okay. All right, so that was the problem. Okay, do you get it, Yan?
I still don't get why cannot append the after appending the path, why we can't use the module.
So you did not understand that if we don't append the path, why can't we use the module?
No. After appending the path, why we can't use the module?
Okay, so that was because still both of my files were in the different location. The script file which was trying to access it was in a different location. Okay, so was this your question that why did we place script.py in Fibonacci folder?
No. Like, do we?
Okay, so I think see, because this was outside. Okay, this was not available here, rather this was here. Okay, and okay, and when I try to run this, maybe I think I removed it from here. Okay, and let me close this and open the script.py. Okay, this is not able to find FIBO anywhere. Did I cut and paste from here? No, right? It wasn't there. Okay. So that's your question, right?
Yes.
This is your question, right? So we are still not able to. Okay, let me just do this. Sorry. What's this? Path. Okay, so see that is gone now. Okay, something wrong. Okay, wrong is, it's not wrong like, you know, it is a the scope, right? You know, it goes from memory when you close it. Uh,
爸爸了，只要是没有良心的，那你这风险太大。人家转帮走了，人家可以把。
hey, hi.
Hi.
I think the audio connection broke off.
Okay.
Okay. See, it has gone actually. You know, this is temporary. This is not a permanent one. Okay. Now you see, I have printed this dot path. Okay. And our path is not over here now, right? So it goes off. Okay. And I think we have to do it again. So let's try that. I mean, you are right. I got a question, right? And why after adding it was not printing, right? I got your point. So when we do append and then this, okay, we have our path added now. All right, you see this? Okay. Now Now your question is that why we are not able to access it.
Mm.
Right.
Mm.
Let me just see. And now, okay, we don't have anything here. Our script.py is here. Okay, let me open this. Okay, so this is your question, right? It is still not able to execute this,
Mm-hmm.
right?
Yes.
Okay, so that's the problem. You see, somehow that's
Mm.
going off from here.
Mm.
And now you see, I tried to do sys.path, and our path has
Mm.
disappeared from here.
Oh.
Right? That is the
Is this?
problem.
Mm.
Okay, so this is like a temporary one. I don't know why
Mm.
it's not working. So I'll check on this. Okay.
Mm. Okay.
The takeaway is that until you have your path in sys.path, you cannot run
Mm.
your or find your script will not be able to find your module. Okay.
Okay.
So what's been happening now here is, I don't know, I have to check it. So I'll take it offline
Mm.
and explain it on the next session. Okay.
Okay.
And
Mm.
what is being happening, you see, right? The path is going off. Okay.
Mm. Mm.
It has to be there in this variable to be able to
Mm.
execute.
Okay.
Okay. Anyways, I'm going to take this question in the next session. All right.
Mm.
Okay. But the idea is clear, right?
Mm.
Okay, great. So sys.path is the list of paths where your module would be searched for. This is what we saw. Okay. All right. Now, what is compiled Python? Okay. Just now we saw that we had we had this folder called we created a folder called Fibonacci over here, and you can see a file created with PYC. All right, this is the compiled byte compile, which I don't think this Notepad++ would be. If you open it with any hex editor, you would be able to see that. Okay, so what this file is, it is a compiled file. It is a compiled Python file. Okay. So when you import any module, the module is compiled into bytecode. Okay, that is why it is called compiled Python file. You can see the name over here. It is called compiled Python file. The extension is PYC. So why is that done? It is just for a faster access. Byte compiled code is faster to execute. Okay, and since we are going to going to use the module a lot of time, that is import, many scripts would be importing the module. So that is why the module is compiled and kept for use. Okay, so The reason says, the slide says, to make it faster to load, not run, right? To whenever any import happens, so that the import happens faster, right? The compilation is done, right? Okay, so the contents which .pyc has are platform independent. They're not dependent on any platform. Okay, this is another part where, okay, so first level of, what was the level of organizing our code? We first organized our code in the form of functions. Then we tried out on modules. Now, when we have our modules in place, what if we have multiple modules? Say this is module number 1, this is module number 2, and we have so on. We have many modules in place. How do we organize these modules is the next level, which is called package, right? So a package is a bunch of modules, right? How you group together your modules so that your project, so if your project has lot many modules, you need to organize your modules too, right? So say based on the functionality, for example, I have got this package, right? So the package is called sound, okay, and the sound package has sub packages, okay. Let me just point over here. This is the package, this is the highest level, right? This is the highest level package. Then you have, this is also a package formats, but we call this as sub package, right? Because this is the child of this package. And then these are like siblings, okay. These are again sub packages. Effects and filters are sub packages, okay. All right, so the top level package is sound, and then we initialize the sound package. Okay, the question arises, what is this new file I can see over here, which is double underscore init double underscore dot py. Remember, to qualify any, so package is nothing but a common folder you have, right? So I can say that this is like, you have the folder sound, and then you have the subfolder formats, and again inside formats you have something. So it's like a folder, right? It's nothing more than a folder. When you go to the file system, it is stored in directories or the folders. So these directories are, how do you call a directory? A package then, okay. To qualify any directory or a folder as a package, it is important to have this file in that folder or directory. If you don't have this file, this special file in that directory, it cannot be called as a package. Now, question again, one more question is that, should I write anything inside this file? It is not important. You can write some initialization routines in this file, but it can also be empty. It is not mandatory to write down anything in this file, but the file has to be present. The existence of this file is what makes this folder as a package. The existence of this init is what makes sound as a package, okay. So you see, in every package you will have this init.py, okay. This is an important point to remember. All right, so as you can see now, in this format sub package, I have got init and I have got multiple modules now, okay. So how do you import from such an organization, right? How do you import from such an organization then? So what do you do? Say for example, let's take this point number A. So you do import sound dot effects dot echo. Now this is called how you access a module inside a package or a sub package. So sound becomes your parent package. This is called complete qualification. This is called importing using complete qualification. You're qualifying your complete path, right? What is the path? You say sound is the main package, then effects is the sub package, and from this sub package you are importing echo module, right? All right, so let's look at this particular point now. Okay, so in this, what we're doing is the same way from sound dot effects, from the sound package and the effects sub package I want to import echo module. Just another way of importing. Okay, the third one, say for example, now in the echo package you have got echo filter as maybe a function. Yeah, right, it's a function. So echo filter is a function which you want to import, so you can qualify it like this: from sound dot effects dot echo. I'm fully qualifying. Notice here that I am fully qualifying the path, starting from the root, starting from the parent package, sound dot effects dot echo. From this package and from this sub package and from this module, get me this function so that I can call it and use it. Alright, so these are different ways of accessing any functionality which is organized in a complete form, that is a package module in form. Okay, this is just like an overview of again a so way of what is package. Again, organizing the code in the form a dot b, where a is the package and b is another package, like, but b is called a sub package because it's inside a. It's a package but it's a sub package. Okay, now as I said, code is organized in the form of folders. So these packages are nothing is other than your folder or directories, just that they have a special file which is called double underscore init double underscore dot py. This is a mandatory file to be placed inside any folder or directory you want to be treated as a package. Okay, every package folder should have a file, even if it is empty, right? But the file existence is important. Okay, this is another way of import. So see, we are covering all different sorts of import we can have. Okay, so let's have a look at this point where you can see from dot import echo. Okay, this is called relative import. Okay, now so this dot is saying that in the current package import this echo module, and in dot dot we are saying, so just like Linux addressing, how we use the directory accessing is now in the parent folder, in one folder up. Okay, I need to import formats and so on, right? That's called relative imports. Okay, These are some of the built-in functions just listed down here. You can just go to python.org and you can find all of this over there. Okay. These are again some of the important packages which are used for different functionalities. Now there might be many more, but few of them are listed over here. Just have a look at this. Okay. So I'll be sharing the slide at the end. It will be uploaded to the LMS. You can access it and you can just go through it, and maybe in your real-time projects you might be using one of these. Okay. So I'm not going to go through each of these today, right? But out of your interest or your current situation, current usage, you can pick these, and you can get a lot of documentation for this. Okay. All right. Yep. So we have reached end of this today. So any questions so far?
Not yet.
Not yet. So the idea of organizing the code, I mean the whole idea of today's slide was this, that we are understanding how do we organize the code better, right? So is that clear?
Mm. Yes.
Okay. So what I would suggest is you try to make modules from now on. Okay, whatever code you write, write it in a functional or reusable way, right? For example, the code you've shown to
Yes.
me, right? For example,
Yes.
the code you have written for the sorting, right? That code could be written inside a function, for example, right? And then the complete function could be written in a script and treated as a module to be distributed to someone. All right.
Yes.
Okay. So okay. So let's discuss about something else now.
Okay.
Or is it enough for today?
I, I think we can discuss something more.
Something more. All right. So let's discuss about some object-oriented concepts. Yeah.
Okay.
Okay. Yep. Great. So let's discuss about the object-oriented programming concepts. Okay. Okay, so we already know that everything in Python is an object. We have been talking this from long time now, and let's try to understand what an object is and what are the usages of it. Why do we need all this, right? So, and we'll understand this in coming slides. Okay, let's try to understand first of all, where does this object come from? Okay, so we have, let's take a real-time scenario where we want to discuss about all the birds, right? So I have got a bird called peacock. and that's a duck. And what else? Maybe what can we take? Sparrow. Okay. All right, so I've got these three birds, and I want to understand about these birds. Okay, what are the qualities of it, and how do they fly, and what are their properties, right? I know that all three are birds. They are in the category of birds, right? And we know that birds have a very common uh, functionality or very common behavior in them is that they can fly. So, can all birds fly? I mean, do you think all birds fly?
Yes.
Yes. I mean, yeah, too. I mean, if not high, but they can fly, right? They've got wings, right?
Yeah. Mm.
Yeah. So what we are saying is that these birds belong to a category of a common behavioral.
More.
Yeah. So do you disagree? So all birds can fly, right?
Yes.
I mean, if not, also we will consider that all birds can fly. Okay, all right. And also we can say that they have got different. Uh, they've got some sort of different behaviors also, that they have got different color and
Mm.
different shapes and maybe different sorts of sounds they make, right? So these are different properties, but they do have some common properties in them. So one of the property is that they can fly, and we can say that they have got some object also in common. Some object in the sense, let's say they have got wings. Wings is what makes them fly, isn't it?
Yes.
Okay, so what we are saying is that this birds is got this birds is nothing but, in our programming language, this is called a blueprint, right? So when you manufacture a product, right, you always get a blueprint of the product, isn't it? Right? Or
Yes.
you want to cast a tile, right? So you got a die for it, isn't it?
Yes.
Right. So that is treated as a blueprint, right? When I say blueprint, in the sense that is taken as a template where all would be following it. All right. So the birds can be treated as a blueprint, okay, where all these specific birds follow this, right? They have this common functionality and data. So what is birds is a class. This is a class we are talking about. All right. So a class is nothing but a blueprint, okay? And these birds, specific birds, are nothing but the objects of this class. And when we say peacock, duck, and sparrow, they are objects. And how do we define objects? They are instance of the class. So actual instance is what? Actual. This is what birds is what? It's a virtual, right? it's just a blueprint or a template, right? So that we can create the actual instances of this blueprint. Okay. All right. So now what we say is that this is a combination of data and behavior, or data and methods in terms of programming, or we can name this as attributes and behaviors, right? Now what are the attributes over here we are saying which are in common is wings, right? So all the birds have got wings. Okay, every bird has got wing, and with the help of wings only they can fly. If they don't have wings, they really cannot fly. Okay, so class is the virtual entity. It is a blueprint. It is just a blueprint. And object is the real entity, where it is called the instance of the class. So an object has got two things, which is data and methods, or attributes and behaviors. Okay, and each object will have this in common. Okay, each object will have, so that's why I'm saying, emphasizing on this, that every bird has got wings, every bird has got to fly, right? Every bird can fly over here, though they can have some attributes which are not in common, and we look at it how we can do this particular portion, right? All right, so the idea of class and object, um, is it clear so far?
Yes.
Okay, good. So let's see what we have got in object oriented programming. So have you done any object oriented programming till now, Jan?
Yes.
Okay, so you have a fair idea of how objects are written.
Yes.
Okay, great. Then it won't be difficult here. It's just a matter of writing the syntax. Okay. Uh, so let's see what we have got. One is encapsulation, and what is encapsulation? It is binding. Basically, it is binding of data and methods, isn't it?
Yes.
Okay, we bind together data and methods, that is attributes and behavior, to form the complete functionality of the object. What is inheritance? So like people inherit, the child inherits properties, or things from its parents, right? Similarly, objects inherit behavior from their parent, right? So what in our scenario will be inheritance is that each of the bird will be able to fly, right? And what do you understand by polymorphism? Any idea?
Mm.
Okay. So polymorphism is can be named as one name and different tasks, right? So it's like you name a function add, but there are two functions called as add, but they do different additions. One adds numbers, another one adds say strings, isn't it?
Yes.
Yeah, so one function but different functionalities. is called polymorphism, right? Okay, and how is that achieved here? That is achieved using, maybe for one example could be that it has got different number of arguments, right? Say for example, this adds 3 numbers, but this adds 2 strings. Okay, so these functions have same name, but they will be called based on their number of arguments, isn't it?
Yes.
Okay, great. Now let's understand exactly why do we need to do this sort of uh, organization again. Why do we need classes? Okay, so you have got a code here. Can you give me a problem? What you see in this case? Do you see a problem? Okay, I have got 2 functions over here. Okay, one is to deposit the amount in the bank account, and one is to withdraw the amount from the bank account. And I'm calling this, I'm saying that, hey, deposit $10 in my account, and then I'm withdrawing $10 from the account. Do you see a problem over here?
Is
Okay. Yeah.
the global balance defined too many times?
Okay, not in the code part. So you don't know. So you cannot use it for multiple accounts, isn't it? But you don't know that which account we are depositing the amount in, correct? So it's like anybody can go and deposit. So this balance is got global, isn't it?
Yes.
This has become global. Anybody can go. So I can go and deposit in your account, and somebody else can go and deposit in your account, and somebody else can also go and withdraw from your account, isn't it? That's the problem over here, right?
Yes.
Okay. Okay. Do you see a problem now in this case? So we have tried to improve this function. Okay, we improve this program. Now we are saying that we have created 2 variables. Okay. What are the variables? One is A. So we are making an account now. Okay. That account returns us a dictionary, empty dictionary. Okay. So this dictionary has got balance, which the balance is 0 right now. So whenever you create an account, whenever you make an account, you get an empty balance account. Okay. So one time I've got account number A. So I have stored this in A and B. Now I am able to differentiate where I am depositing the amount, isn't it? But is that still a good idea? Do you find any problem still? So I'm just going and depositing $100 in my account A, and then I'm going and depositing $50 in account B. Okay. And withdrawing $10 from each account B and A. Okay. Okay, the problem is that it is too much repetitive. Okay. Now see how it is actually not a good idea to organize such sort of code in the form of functions, right? So when do you want to make classes? When do you decide that you should make a class? So when do you see a need of a class, right? So say for example, this is kind of a real life example, right? Isn't it? Okay, and when you find some example like this, that you're going to make a lot of accounts, right? That is where you don't want to repeat the code, correct? You don't want to be specific, rather you want to organize in a very better way. So that's why this is called as, you know, better way of organizing code when you have a real life example. Okay, now what I'm going to do is what I have done in this case is that it looks same. Okay, it looks exactly the same. There is no problem code wise in this case, right? When we try to attempt uh, creating creating a function, so what is repetitive over here is just another function, right? What we have got is just a one more function which is extra over here. Okay, okay, so let's see how we define a class. Okay, as we said, we are saying that class is a blueprint, right? Now this is how you define your class. Class is the keyword. Okay, your class is the keyword, and then you give the class name. And how do you give the class name? The nomenclature you use is camel case. All right, do you understand camel case?
Yes.
Okay, so camel case is what you follow for defining a class name, giving a class name. Okay, give the class keyword, uh, give the class name and colon. What is this method over here? Okay, so have you heard about constructors?
Yes.
Alright, so this is the same as constructor, but in the case of Python it is mostly called as initializer. Initializer method. Okay, all these three are methods. Okay, now this particular method is called initializer, and why it is called initializer
Yes.
is because it initializes the data of the class, right? Data of, what is the data here? Balance becomes the data. And what are the methods? Withdraw and deposit becomes the methods, correct? So withdraw and deposit are going to work on balance. They are tightly coupled, isn't it? Right? So whenever we create an object, and how do you create an object of this class? Now we have defined a class which has got an initializer method, which is initializing the initial balance in the account. Okay, I've got a bank account now. Okay, now my bank account has to be with some balance, isn't it? I mean, you might have a salary account maybe which allows you to keep no balance in the bank, right? But most of the accounts need a minimum balance to be maintained in the bank account, isn't it? Right? And then there are two common operations which will be common to all the bank accounts, right? May it be current account, savings account, or maybe other accounts, right? Every bank account will have this transaction method, right? Anybody can go and deposit to the account, or anybody can go and withdraw from the account, right? Okay, so this becomes our blueprint, a class for which we'll be making the real-time objects. So how do you make an object of the class? Is this way, right? So you give the class name and then the small bracket open and close, all right? And your object is created. Now what happens is, whenever your object is created, this initializer method is called, okay? So for example, what happens if you do this a is equals to bank account? Your balance is what? $100? No?
0.
It has to be 0, right? Because the initializer method will be called as soon as you create an object. As soon as you create a bank account, the initial balance is going to be $0. Alright? Now rest of the things are very clear. I think it is all same, just an extra thing which is called self. Right? You see a self as a mandatory argument in all these methods, isn't it? So what is this self? What is this self about? Okay, self is, if you have heard about this pointer, have you heard about this pointer?
Yes.
So what is this pointer?
Point to the instance itself.
Yeah, so it's the same here. So self is nothing but it points to the object itself. Okay? Alright, so self is similar to this. Alright? Okay, great. So every class method is supposed to have this self as the first argument. Okay? So self is nothing but it is the reference to the object itself. Okay? Okay, so class is a keyword, it is an encapsulation. Self defines the scope of variables. Okay, few of the points. Okay, class can have functions. Class has got functions, isn't it? Okay, so now while defining, we are made available self, but we don't pass. When we don't pass? We don't pass when we are creating object, okay, or we are calling the method. So for example, when we are we tried calling the method on the object. How do you call the method on the object? So say for example, now my object is account with the name A, and I'm trying to deposit an amount of $100 to the A account. Now this deposit method is called not with self. You see this? You don't have self over here. Alright? You don't have self over here. It has got only one argument. So while calling the method, you don't put self. Okay. Whereas when you're defining the method, there has to be a self. Okay.
So is there any other variables other than self when you are defining a function in the class?
Come again, sorry.
When you are defining a function in the class, is there any other variables other than self in the position of the self?
Okay, so what I understand from your question is that when you're defining, so we have got self as the first argument, okay, and we can give any number of arguments followed by self. So self is the first mandatory argument when you're defining the method.
Mm.
Is that your question?
Yes. Does it have to be self? Is there any other variables?
Okay, so you are saying that self is the name self mandatory required.
Yeah. If we don't put self there, what does it mean then?
Okay, all right, I get it. So that would mean that it is not a class method. Okay, that would become a static method then. Okay, so that will, so all these methods right now here are what? Class methods. Okay, when you remove self from here, okay, you are not supposed to use like this inside the method then. Okay, because that method is not supposed to use any of the class members. Okay, does this answer your question?
Yes.
So primarily most of your class methods, not most, all of your class methods have to be having self here. Okay, if at all you are defining any method which is supposed to be not operating on your class members, you can define which is called static method. We'll discuss about this. Okay, so for all class methods, self is a mandatory requirement. Okay, all right. Okay, so what does this say? Init gets called when we create object. Okay, and how it is useful, we'll see that in following slides. Okay, so for example, let's say this one tells clearly, and this one also explains about the inheritance. Okay, now we are trying to have a bank account. That's true, we have a bank account, that's fine, but now what we are trying to have is a minimum balance bank account. Okay, till now our bank account had how much balance as the minimum? It has $0, isn't it?
Yes.
Now we are trying to make a bank account which has to have some amount of minimum balance, correct?
Yeah.
So what do you mean by inheritance is you inherit something from your parent, isn't it? You inherit
Yes.
so we all people inherit some, say, genetic or properties, or land properties or anything from our parent by default, isn't it?
Yes.
Similarly, our this so we are creating another class which is minimum balance account, and we are saying that this is another class which will be inheriting properties from the main bank account. Okay, now since this bank account has got what it has got, it has got some balance, it has got withdraw and deposit. All right, now we are restricting our thing to a minimum balance now. Okay, so we are saying that yes, my account is going to be a bank account, that's true, but now it's going to be a minimum balance account. Now we are saying that we are restricting that we cannot deposit, we cannot have a balance less than this minimum balance in our account any time, any point of time. All right. So how do we do that? Okay, that is accomplished using the initializer method, isn't it? So initializer method tells that, hey, I'm going to have not balance but minimum balance now, and we'll see how it is. Okay. So and also the policy of deposit will not change. Will it change? So anybody can go and deposit any amount, isn't it? Okay, but the withdrawal policy would change because we cannot go below our minimum balance, right? So we need to check if balance minus amount to be withdrawn is less than minimum balance. So what we are saying, we are printing sorry, minimum balance must be maintained. Correct?
Yes.
So what are we trying to do is, this is called inheritance, that we are inheriting properties from the parent. Who is the parent here? So this is inside the brackets you give the parent or the parent class, to be very specific. Okay, this becomes the child class and this becomes the parent class. So we are inheriting all the properties, that is our bank account is going to be having a balance, it is going to have a withdraw and deposit, but the withdraw is overwritten. So now when I try to call the withdraw, which withdraw will be called, from the parent or the child?
The child.
The child first, right? Because it has overwritten the property. Okay. So is the idea of inheritance clear?
Yes.
Okay. Now give me the answer of this. So which one is the parent class over here?
A.
A is the parent class, yeah. And B is the child class, which is inheriting from A. All right. Now what should be the output?
The first line is A and B.
A and B. So I'll just write down, okay. So your output is A and B, isn't it?
Yes.
Okay, all right. Okay, let me just write like this, A and B, isn't it? Yeah.
The first is A. The second is B.
So what's your output?
A and also A and B.
A and B?
Yes.
So you're saying A and B in both the cases.
Yes.
Okay, and why do you think so? How did you come to that conclusion?
Mm, the first line print A dot F returns A dot G, which returns A.
Okay, which returns A. Okay, all right.
And the first line is B dot F. B dot B inherit. Oh,
Yeah.
okay. B inherit the F function from A,
All right.
which go to
This function F. Yeah.
yeah, which goes to the self dot G.
Yeah.
Is C dot G
All
returns
right.
B.
Great. Super. Very nice.
Yeah.
So this self will be pointing to the object itself,
Mm,
right?
yes.
And in this
Yes.
case, the object would be B.
Mm,
Yeah. Great. That was fantastic.
okay.
Okay. So we'll stop here today. Okay, we'll continue our discussion on this in the next session.
Okay.
All right.
Okay.
So I hope this was
Okay.
clear. The one thing which I need to give you is that why wasn't that working today? I will have to see that it is supposed to
Mm,
work in that way.
okay.
All right. So
All
thank
right.
you very much. Yeah. Yeah. Go ahead. Go
Thank
ahead.
you.
Go ahead. Go ahead.
Uh,
You were asking something.
no.
No? That's fine.
Mm-hmm. Yeah, that's fine.
Okay. Thank you very much for joining today.
Thank you.
All right.
Goodbye.
Goodbye.